Well, our disk method works great if the shape that we're revolving goes all the way to our axis of revolution. But if the shape we're revolving does not go all the way to the axis of revolution, it leaves us with a hole in the middle. So basically, if we take this shape over here and then we revolve it around our axis of revolution here, we end up getting a washer. In other words, this empty spot right here, when revolved, ends up being a hole in the middle of our disk, so it ends up being a washer. Now, to find the volume of this whole washer, you would have to do the volume of the whole disk minus the volume of the hole. Well, for the most part, it would be pi times your big radius times your width minus, you got to do your hole, which would be pi times the inner radius times your width. So you could factor out the pi, and you could factor out the w, and then you get your volume of a disk being this. So for the most part, when we extend this whole idea to integration, you're going to put your pi in front. Your w, your width, once again, is your dx. You do your outer radius, the big radius, minus your inner radius, the smaller radius, each one of them squared. And then you'd have your bounds. So basically, you're doing the whole volume of the whole thing and then taking away the volume of that hole that you're missing. So for the most part, if we take this right here, we're going to have our square root function, which is our sideways parabola right here, and our squaring function, which is your normal parabola right here, and we're revolving these around the x-axis. Now, if you look at the shape bound between those, we can see that it crosses at 0, 0 and at 1, 1. Now, if you didn't know that from your picture, all you'd have to do is take your two functions and set them equal to each other, and then you could square both sides. Then you could set it equal to 0. Then you could factor it. Then you have two things multiplied together to give you 0. You set them each equal to 0. So that's how you get 0 here and 1 here. Now, we're taking this shape and we're revolving it around the x-axis. So we actually have to go the big radius. Your big radius would be going from here to here. So basically, it's your top function to your axis of revolution. So your top function is your square root function. And then we'd have to subtract your smaller radius, the whole, this part right here, which is really your bottom function to your axis of revolution. So, by the way, if we did take this bluish shape and revolve it around your x-axis, you would get this shape right here. So it's kind of a funny looking bowl. The outside's kind of like a normal bowl, but the inside's almost like a little funnel. So if we do that, here's our washer method. We got to leave pi in front. We have our bounds. Well, our bounds here are, we're dealing with x. Is how far your shaded region goes left and right. Starts at 0, goes to 1. So your bounds are this. Then we have to go our big radius, the outer radius, which is your square root function minus your axis of revolution, or just x squared. Then we got to go your inner radius. Your inner radius would be this green part, which is your x squared minus your function, and then we have to square that. Now, if we simplify this, we square that, we just get an x. We square this, we get an x to the fourth. Now, that's pretty easy to integrate. So then you just do your normal integration, increase your exponent by 1, undo it in front. Plug in your 1 minus what you get when you plug in your 2. Or your 0. And in this case, we get 3 pi over 10.